topic is trig identities, but we've actually covered some trig identities already. So one of the trig identities we spoke about before is something called the reduction formula. So if I said something like, that would be an identity because the left-hand side is equal to the right-hand side. Or we could have something like that would be a reduction formula, or we could use a co-ratio, and that could be something like that. We covered a lot of this stuff in lessons 3 to lesson 5. And so if you are new, if you weren't here for those lessons, you would probably be a bit like, huh? But for those who were here, can you give me a thumbs up if you understand why these things are equal to each other? Why the left-hand side is equal to the right-hand side in each of these cases. Okay. So these are one form of trig identities that you need to know about. An identity just means one side is equal to the other. But there are some other identities that I haven't mentioned that I want to put in focus today. The one identity is called the quotient identity, and the other one is called the square identity. And I'll show you why they are true in a moment. But what are they? What is the quotient identity? What is the square identity? Does anybody have any ideas, or maybe they've heard it in class? What do you think it's going to be? So the quotient identity is normally something like when you have tan of x, and you can write tan of x as the sine of x over the cos of x. That's called the quotient identity because you've got something divided by something, or you've got a quotient. You've got division. So this is something which is generally true in trigonometry, and we use it all the time. I see Paul has got that. Now, what about the square identity? Who knows what the square identity is in trigonometry? There's going to be some squares involved. I'll give you the start. The start looks a bit like that. If I say sine squared x plus cos squared x, Tebogo, what's that going to give me?
Hi, sir.
Hey.
Isn't that going to give you 1?
Perfect. Yes. This is called the square identity, and it's rather puzzling. It's rather interesting. I'll show you now why it works, but you just have to learn that. So sine squared x, or sine squared a variable plus cos squared a variable, is equal to 1. Sometimes this identity is rewritten in 2 other ways. I'm wondering if any students can, if any students know of the 2 other ways that this is rewritten. So Veda has suggested that I go 1 minus something, and Tebogo also has, well, let's go have a look there. Tebogo, what do you know about the other ways this can be written?
Isn't it going to be 1 minus cos squared equals to sine squared x?
Yes. So you can make the sine squared x the focus of the identity, or you can also do it the other way around and write it like this. This is exactly the same identity. The only difference is we're focusing on a different part of the identity. So in this case, we focused on the sine. And in this case over here, we focused on the cos. And in this one over here, we basically just focused on the 1. This is the same identity. There's 2 main identities that are going to be in use today, but the second one can be broken up into other ways. And so I just want to give you a moment to write that down, and also to ask any questions, or if you feel like you understand, you don't have to have even seen this before, but you just understand the statement that I'm making, that sine squared x plus cos squared x is 1, and the one above, give me a thumbs up. If you feel a bit lost now, give me a thumbs down. Can everybody see the board okay? Can everyone see the screen okay? I know.
Yes, we can see it,
Okay.
Mr. S.
All right. So let me show you why this is true, but we are going to come back to these identities today. This is going to be the main focus. So if you think of the cast diagram, in previous lessons, I told you that we think of trigonometry as being on a Cartesian plane in grade 11, with this radius or terminal arms kind of swinging around, giving us an angle. Now, if you think of this as the O, this as the H, and this as the A, you can see how it relates to grade 10 trigonometry, where we focus a lot on the idea of SOHCAHTOA. It's the same idea, except it allows us to handle angles that are bigger than 90 in a way that makes sense. Now, if you think about how sine of theta is written here, the sine of theta is just going to be y over r. So here's the y, and here is the r. So that's the sine of theta is y over r. The cos of theta is just going to be the x over r. Give me a thumbs up if you follow where that comes from in the drawing so far. Okay. Now, if we say sine of theta over cos of theta, it's the same as saying y over r over x over r. And then if you think about dividing by a fraction, you can divide by a fraction by multiplying and cross-multiplying or top and timesing. You get that. And then you can cancel these r's and you get y over x. Now, if you look at y over x on the drawing, y over x is the same as over a, which is the same as tan of theta. And so that's how we get the quotient identity. That's where it comes from. That's why we know that it's true. Quotient identity. Now, for the square identity, we do a very similar thing in that we write out what sine of theta is. So we know that sine of theta is y over r, but if we know it's y over r and we want sine squared theta, it will just be like that. And the same for cos. We know cos by itself is x over r, but then x over r squared is going to be that. Now I'm going to go to this part of the thing. So I've done that bit. Now I'm going to expand it to be like this. I just want to check that everyone is with me up to that step there. Give me a thumbs up if you are here with me over here. Thumbs down if you feel like there's too many y's, x's, and r's. Okay. Cool, cool. The next step is to notice that the denominator is the same. It's r squared and r squared. So I can keep the denominator r squared. On the top, I have x squared plus plus y squared. Then, well, here comes the clever bit. X squared plus y squared is from this right angle triangle. So there's x and there's y. And so we know by the theorem of Pythagoras that x squared plus y squared must be r squared. And anything over itself is just then going to be 1. And that is why we can say that sine squared theta plus cos squared theta is 1. And so those are the two identities that we use a lot of. Okay. That's not the main point of the lesson. The proof isn't the main point of the lesson, but I just wanted to show you that these two identities aren't just made up. They are grounded in real math theory. Okay, so Alyssa, if we look at, yeah, we'll go through it again because I went a little bit quick there. So if we look at the first step was to realize that sine squared theta can be written like that. And then cos squared theta can be written as x over r and then a squared. Then what we did was we applied the power of 2 to everything in the bracket. And so we get y squared r squared plus x squared over r squared. Then if the denominators are the same, so we get x squared plus y squared over r squared. And then the clever bit at the end is just to realize that from this right angle triangle, x squared plus y squared is r squared. So when I've got x squared plus y squared, I can rewrite it as just r squared. And there was already an r squared on the bottom, which means that that must be 1. And so since this started, we just go back to the beginning. What is sine squared theta plus cos squared theta? It's just going to be 1. So let me show, the main point of this lesson is to show you how these are used. But that is, if you want to take a screenshot, you can now. I'll even take away some of the jumbling. Because the main proof is just this column here. So take a screenshot if you'd like, and then I'll show you how it's used. Okay. So here is a trig expression, and I want to ask you to simplify it. So I want you to simplify it, make it simpler, using either of the two identities that I have spoken about today. I'll give you 30 seconds to do that. Can you simplify that? And then write your answer in the chat. What is the sine of alpha divided by the tan of alpha? I'll give you a tip. Focus on the tan of alpha. Ask yourself what you can do with the tan of alpha that might simplify something. Who would like, so I've made the substitution. Who would like to tell me what the next step is going to be? So I've rewritten tan as sine alpha over cos alpha. How do I get from there to my final answer? Who would like to share? So Tando said tip and times, or Cornelia said tip and times. I think I agree with you. Now, what tip and times is an informal way of saying is you're going to basically take the fraction that's here and say, instead of saying divide, you're going to say times. But when you times, you have to tip the denominator and numerator around from the fraction that's there. So you get cos alpha over sine alpha. And that is equivalent to the division over here. Now, the next thing that's great is that you can think of this as over 1. And then you can think of this as equivalent to 1, because it's over itself. And the final answer would be cos alpha. And so this whole thing can be simplified to the cos of alpha. Okay. So that was just the sort of warm-up question, but I think, we're still just starting out. I'll call that number 1. I want you to try and simplify number 2 now. So number 2 at the bottom of the page there. Can you simplify number 2? I'm going to just grab some water while you're doing that. Who's got a tip for us? Where would you start when you want to simplify this? I think I'd probably start with the tan. So if I replace the tan of theta with the sine of theta over cos of theta, that's great. But now how do I make this simpler? What's going to be my next step? You can put it in the chat or you can raise your hand. We need to think about what are the steps. What's our strategy to make this expression simpler? Paul, let's unmute you. What do you have to say about strategy here?
Hello, sir.
Hey.
So we could cancel out the cos theta, and then from there we'll be left with 1 minus sine squared theta, which therefore simplifies to cos squared theta.
Yep. Chop, chop. So your two steps were to cancel out equivalent expressions and then recognize that the square identity is here, and that can be written like that. Perfect. Thank you. All right. Let's do another one. Let's do number 3 and number 4. So here's number 3 and number 4. Both cases, the key word is to simplify. Can you simplify number 3 and 4? I'll give you some time for that. And so think about what are your strategies. And Paul gave us a couple of strategies for the previous one. Can we reuse some of those strategies, or do we need some new ones? Give it a go. What happened to tan? Good question, Lolo. So there was a tan, and it was replaced by this over this, because that is identical to the tan of theta. It's a trig identity. And once we had replaced it, it meant that we could cancel out these equivalent expressions on the top and the bottom. They're equivalent together to 1. So that's what happened. So Tondalwetu, would it still have given us the answer if we change 1 to the identity sine squared theta plus cos squared theta? Okay, so you have to deal with what you have, in the sense that if you've only got 1 minus sine squared theta, you have to deal with that first. You can't change that. So I'm not sure exactly how you have to deal with what you've got. You couldn't make up a new identity. You could replace the 1 if you wanted. You could replace the 1 with sine squared theta plus cos squared theta. I think that's maybe what you're asking. In which case, if we did that, we would still get cos squared theta, which is completely fine. So I think that answers Tondalwetu. Yeah, perfect. Oh, I must have got it through my I don't know, ESP or whatever they call it. Okay, so let's try and do number 3. Who's got some tips for number 3?
Any ideas, guys?
Okay, and Paul, what do you think?
So I think that we should first simplify what's in the bracket, and then we can continue from there.
Okay.
So then what I did, I wrote 1 plus sine squared theta over cos squared theta.
Okay.
And then if we simplify the terms inside the bracket, we get
Okay,
sine
so
squared theta.
when you say simplify, what are you doing to simplify this step?
Oh, okay. So I added the fractions, and then yes.
Okay.
I added 1 plus that fraction.
Okay. So did you make, there's 2 ways you could do this. I'll show you both ways in a moment. But did you make the one cos squared theta over cos squared theta? Is that what you did?
No, sir. So what I did basically, I said I cross multiplied, sir, to get like a common denominator. So
Did you multiply this into
no,
here?
no. Inside the
Okay.
bracket, sir. I can't explain this properly, but then I took 1 multiplied by the cos squared theta, and then sin squared theta times 1, and then over the denominator cos squared theta.
Yeah, so I think this is what you, I
Yes,
could be
yes,
wrong, but did you do something like that?
yeah.
Okay, so
And
then you have, okay, so it's completely fine to do that. Let me just put, you don't have to do this like this, but there will be some people who did it like this and it's completely fine. And then did you go cos squared theta plus sine squared theta?
Over cos squared theta, yes.
Okay.
And then the
I'm
cos
going
squared
to show you another, yeah. And then,
so the cos squared theta inside the bracket will cancel out, but then
okay.
it's going to leave us with sine squared theta over cos squared theta.
And wouldn't this one over here be 1? Because of, isn't this the same as 1?
Yes, yes, it is. Oh,
Okay, and so then you cancel out this, and your final answer is
1, yes.
1. Okay, perfect. Absolutely perfect. I'll show you another way we could have done it. The other way we could have done it is we could have multiplied this into the bracket. And if we did that, 1 times anything is cos squared theta. And then over here, we would have cos squared theta times the thing that was in red already. So and then, I don't know if anybody else did it this way. What would you do in this next step? So we've got our 2 ways of doing it next to each other. We hopefully get the same answer. Otherwise, something's gone wrong in the world. What would we do in this next step? If anybody did it like this. So what we would do is we would, Teboho agrees, we would cancel those out. And then we've got left with cos squared theta plus sine squared theta. What is that going to give us? Well, good for me and you, it's going to be 1. And so Letty agrees as well. So there's 2 different ways to get to the answer. Some of you have done more of this than others. It doesn't really matter how you get there. As long as you're consistent, you'll get the same answer. But that was a tricky one. Why is it plus, not times? Because this is a separate term. So this term over here is one term, and this thing over here is another term. And so that plus sign has to stay there. Okay, let's try and do number 4, and then we'll do a brain break. So try and do number 4. And then while you're doing number 4, I'll take additional questions from the class. I know that that would have confused a few people. Okay, Sandita, I think you are suggesting the answer. We'll see in a moment if others agree. I think people are spotting this quite quickly, that this can be rewritten as sine squared theta, and that this can be rewritten as cos squared theta. Now the question then becomes, what is that going to be? Can that be simplified any further? And I think Owetu, Mpo, Bongo Kosi are all agreeing that this is tan squared theta. So watch out for the squares here, because if you've got sine squared theta over cos squared theta, you don't just get tan theta, you get tan squared theta. let's do a quick little poll. Give me a thumbs up if you've understood kind of what's going on so far in the lesson. Give me a thumbs down if you feel a bit lost. I just want to get a feel for the group feeling so far in the lesson. It just helps me know kind of what pace to use in the second half of the lesson. Okay, everyone, it is time for a brain break. And so what I'm going to ask you to do is to please stand up. I do see those thumbs, so there are some thumbs down, so I will bear that in mind going forward. And I want you to just stand up with me. So step away from the desk and step away from the desk. And let's see if we can just take a deep breath. And I'm going to adjust my camera so that you can see me. All right, let's just swing our shoulders quickly and take a nice deep breath and breathe out and breathe in and breathe out. Okay, let's roll our shoulders, roll them back. Let's roll them forward. Let's stretch our necks. Hold them to the side. 1, 2, 5. Switch to the other side. 3, 4, 5. Okay. Maybe just check that your neck muscles are. I can feel my left side is quite tight. Oh, just stretch your neck out. Then let's do some circles, small circles. And then let's do bigger circles. And then let's do nice big ones. Let's reverse, go backwards, small circles, bigger circles, bigger circles. Okay. Then it's time for a midline crossing exercise. Take your right hand, put it on your nose. Take your left hand and put it on your right ear. Okay, now this hand is going to go to your nose and this hand is going to go to the opposite ear. See if you can switch. And then see if you can take this and switch it back. And then see if you can switch it back again. And then see if your brain can figure out the first time you do this, you should find it quite hard. Some of you are pros because I think you've done this with me before.
I don't think I'm doing it right.
Okay. And then let's do some jumping jacks. So get those arms ready. Make sure that the space around you is clear. And let's do 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Connor literally looks like he's just moving his arms.
This is not a real one. Remember your heart rate.
No, that was not a jumping jack.
Yeah, they're disqualified. You have to go again. So the whole idea is that your heart rate goes up. If your heart rate goes up, the blood moves around your body. Your brain feels a bit more like, okay, I can, click save as for the first half of the lesson. And then it's going to freeze you up to start again in the second half. Before we do that, let's have a go at this little puzzle. It's called Math 24. And you need to use 4 of the numbers, or all 4 of the numbers to make 24. Can you do either of these cards here? Can you make 24 using all 4 numbers? And you can only use plus, minus, times, divide, and brackets. See what you can do. Okay. Well, where to has a suggestion for the red one. And so does iPhone. Who else has some suggestions for the red one? Nkosi agrees. So the red one seems like Emmanuel. Oh, it's different. Oh, that's nice. So there's two ways I've seen to do the red one so far. The one is to go 6 times 5 minus 3 plus 3. And then the other one I just saw now, in manual, 5 times 3 plus 6 plus 3. That also gives us 24. And you've used each now.
Nicely done, guys.
Fantastic. Yes. And Tebogo, I agree. And Beverly, I agree. Or where to the blue one? Sure. Okay. Can you do the blue one? What about the blue one?
They want you to turn up the heat, Mr. Ace.
Oh well, listen. Like there is a 3 dot. I've heard rumors that there is a 3 dot, so we can always bring that to the table.
Ooh. Careful what you ask for, guys.
I was actually going to look. I'll go and find them. Okay, so I agree with that. And Charlene, okay. The people have spoken. They said, listen, don't disrespect us. Show us a real challenge here.
Give us a
All right.
real math 24.
I'll see what I can find for the next one. Nicely done, Sipo. Very good. I think you guys have got this Maths 24 card waxed. So let us return. Actually, before we do, just a quick question to you, and you can be brutally honest. Did you find the brain break helped you reset your concentration? So just give a thumbs up if you think yes, thumbs down if you think no. I'm just curious what you... All right. Yeah, that's what I think. If I was a student, I'd want to do a brain break, even if it felt a bit silly. I know that the net benefit would be, I would still feel like when I started again, like my brain's restarting. I think there is even a little thing about you remember the most at the beginning and the end. Okay, cool. Let's do this. People, just think of this is what hard work looks like. If you want to improve, want to do well, it's just about practice, practice, practice. So let's keep practicing. And so this is the next one. I want you to simplify this for me. Simplify this trig expression using the identities that you have learned about today. What do we think the first step is going to be? What do we think about strategy? I think the first step is going to be to handle this thing over here and to realize that it can be rewritten. And I think it can be rewritten as sine squared beta. Aha, and then I can rewrite this as tan squared beta. And then I'm left with that. And then anything minus itself will be equal to 0. So that will be equal to 0. Okay, looks like you guys are getting better and better at this every time. So let me give you a tougher one. Can you simplify the following expression? Where you've got sine theta minus sine theta times cos squared theta over sine squared theta. And we might need some tips from the group to get us going, but for the moment, you do the best you can do. Yes. Oh, that's a good hint. That is a good hint. So, okay. So while others, so in the previous one, I first started by replacing the 1 minus cos squared beta with that. And then what I realized is if I look at this whole thing, sine squared beta over cos squared beta is the same as tan squared beta. And then I've got something minus itself, in which case, if you go 2 minus 2, it must be 0. I hope that helps, Ongani. So the hint that's been given for the next one is to say factorize. And the reason is there's nothing you can really do to replace something in this question. The only thing you can do that I can see is to take out the common factor of the sine of theta. And then you have to decide what goes in this bracket. So I want to know what goes in this bracket. That's the next question. What goes in the next bracket?
We love to hear your voices, guys.
Yeah. So if I know that there's going to be a 1, oh, there we go, Nkosi. Thank you, cool. So 1 is what you would get to get the first bit, and then Leti and Ayanda, you would have cos squared beta here. Okay, now, what's the next step? Who wants to tell me what the next step is? It's still not obvious how do I make this simpler? Change the denominator. Okay, so I'm going to be in the denominator, and I am going to have to deal with this and realize that this one over here, yes, Leti, let's go to you. What would you do?
Okay, so what I'll do.
We have a little bit of feedback. No stress. There we go. Can you hear me? Oh,
Yes. What I'll do is that I'd say 1 minus cos squared theta is sine squared theta, and they cancel each other. Then the
that is
answer is sine theta, I think.
yeah, you're 100% correct. So, thank you, Leti. So you get sine of theta. So that whole complicated looking mess here simplifies down to the very simple sine of theta. Very nicely done. So what was the strategies we used this time? This time we had to factorize the top line. So we had to factorize, and after we had factorized, we could then replace identities within the expression. So we replaced this with this. Okay, let's try another one that's somewhat like that one. So I want you to simplify this one. See if you can simplify this one. And then if there's any questions about the last one, now is a great time to ask. Okay, so Tandal, if you look at the previous one, where did I lose you on the previous one? What part of the previous one did I lose you at? Was it at the factorizing step? Or was it when I replaced the stuff in yellow with the blue stuff? Okay, the factor, yeah, that was tricky. So when you think of factorizing, if you think of this top line, sine of theta minus sine of theta times cos squared theta. So I'm just focusing on the top line. Are you okay with recognizing that the sine of theta is a highest common factor? Would that make sense to you? Okay, fantastic. Now the next thing is, if I do this part, I have to ask myself, what do I need to multiply by to get back to that? And there's always what I call a phantom 1 sitting in front of that. So that's where the 1 comes from. And what's left behind? Well, there's just the minus is left behind and the cos squared. So you go 1 minus cos squared theta. Okay, so then now you have to recognize that this part, 1 minus cos squared theta, can be rewritten as sine squared theta. And on the top, you've got sine of theta. Now remember, that was just the top. The bottom, there's still a sine squared theta. And so that's why, if I put that back, that's why that could cancel. Okay, glad to help, Tandaweti. Okay, now, what about this one on the top here? I think that a very good idea here is to take out the common factor again. It's not the only way you could get the answer, but I think I would do the same thing because there's a tan squared theta and a tan squared theta here and there. Now, what goes inside the brackets? What goes inside the brackets? Who would like to tell me? What do you think goes inside the brackets?
I think it's going to be cos squared theta plus sine squared theta.
I understand cos squared theta is there, and then you're saying what's left here, it's sine squared theta. I completely agree. What can you do from that step?
You factorize the bracket, which is going to be 1.
Okay, well, you wouldn't even factorize it, you would just replace that identity with 1. So times 1, anything times 1. Did you get tan squared theta as your final answer?
Yes.
Perfect. So we should get tan squared theta. Nicely done, Tibble. Are there any other questions about how we did? We are getting harder now. So anybody else have any questions about how we did this? The other method? Actually, I don't know if there was another method. So some of you might have done this where you replace the tan with sine squared theta. So I can see some of you doing this, and then you went sine squared theta times this. Now, if you did that, this would cancel out fine, but then you stuck with a little bit of a problem for this next bit, in which case you're going to have to, you are going to, no, you would actually, if you did that, you would then have to bring the top line, okay, I'm not going to go down that route. It is possible to get the answer from this, but you should get tan squared theta. Because of time, I'm not going to go that route. It just would take a lot longer. Okay. And the other thing is you wouldn't be able to cancel out these sine squared. So a lot of students would get stuck here. You'd say, look, I can cancel these out, but you can't cancel them out because the sine squared would have to be on the bottom. And so you can't do that. You actually probably have to work with the fraction cos squared theta as the denominator. Okay. I want to show you one more type of question before we finish today. And that is going to be, let's have a look at that, this one. And we're going to do this one together because we're going to start the next lesson with this. This is a sort of more typical exam type of question. Show that this one over here is equal to that bit on over there. And when we do this, there's a very definite technique that we use. So this is what we call a trig identity proof question. And we have to show that, or we have to prove that this is equal to this. Now, the first thing to know when we do this, yes, I love it, Veda. This is called the left-hand side, and this is called the right-hand side. Now, whenever you work with a trig identity, you normally work with the harder side first. Of the two choices, left-hand side and right-hand side, which one looks more scary to you? Which one looks harder? I definitely think it's the left-hand side. Yes. So what I do is I write left-hand side equals, and I write sine squared theta plus cos squared theta plus tan squared theta. And all I'm going to do is work with the left-hand side now. So life has got a little bit easier. What is the first thing I can do to make this a little bit simpler? If I look at this expression from the class, I'd love someone to come online and tell me what things can we replace to make this simpler? Let's go to Kat. Hey, Kat.
Hi, sir.
What do you think we should do?
So I would first change tan squared theta to sine over cos.
Okay, I totally am with you. It's definitely going to happen. But before we get to that, is there anything else you spot?
Sine squared theta plus cos squared theta is equal to 1.
Perfect. Okay, so you're happy for us to do that.
Yes.
Now let's do the second thing you said. You said change the tan. Is this what you meant? To change that?
Yes, sir.
Okay, perfect. So we've done 2 steps so far. However, the goal in these types of questions is to make the left-hand side look like the right-hand side. Now, we're not quite there yet. We're almost there. I would like some suggestions from the class as to what the next step might be. Let's go to Letty. Letty, what do you think the next step would be?
So I think we should move one side to the other side of the equal sign and then divide. I don't know.
Okay.
Yeah, I think
Okay, here's the
sine
problem.
squared theta over cos squared.
Okay, I know what you're trying to do. The problem is we only have one side to work with. So we're only allowed to work with the left-hand side, and then we have to make it look like the right-hand side. So we're kind of stuck in the box. The thing that I noticed is the right-hand side only has one term. So we need a way to glue these two together. Maybe Rhea can help us. I see Rhea's hand is up.
You can find the lowest common multiple between the two, which is cos squared theta.
Aha, so you're saying, are you oh, I'm echoing. Let's see if we can unmute again, and then maybe I think we just muted you as a precaution there. So is that what you meant?
Yes, and then cos squared plus sin squared theta is 1. Then you get 1 over cos squared theta.
Okay, I think you're perfectly correct. Let me just write this out so everyone follows. So what we did was we rewrote the 1. So let's make sure we can all see this. 1 can be written as anything over itself. And because we really wanted denominators of cos squared theta, we rewrote 1 like this. And the reason Rhea did that was because now the denominators are the same. And once the denominators are the same, we just write it down and we add the numerators. Then Cody says, so cos squared theta plus sine squared theta is 1. So that bit is 1. And this is cos squared theta. And luckily, this is now equal to the right-hand side. And so we proved it. So that is the type of question which we will continue with in the next lesson. Today was all about building awareness of the different trig identities, the quotient identity and the square identity. And we've kind of played with them a little bit. And we've kind of seen how the different types of questions look. In the next lesson, we'll start talking about how do we begin to solve trig identities like this. And you'll notice that by the end of that, it won't feel so bad. So yeah, I think it was really nice teaching you today. Lebo, if you could put the poll out for the students, and if you could just give us some feedback about how you found the lesson today, then That would be super helpful for our planning. And then are there any final questions for today that I can get to? Are there any questions or things you want me to clarify?
Please fill out the poll before you go, guys. Really appreciate your feedback.
And Cecilia, we will start with, if I remember correctly, it's analytical geometry. It will be on the website by Wednesday, but I'm pretty confident it's analytical geometry going forward, yeah. So like perpendicular, parallel lines, some rhombuses, parallelograms, midpoint distance, that type of thing. Are there any other questions or comments before we finish the day? Please do give us your feedback. We really value that. Okay, well, then I'm going to call it a day for today.